Greetings to everyone. We are Group 5A from Taylor's University, and today we're going to talk about our product, Napan, the renovated silage. Before we start, we would like to introduce ourselves. Supervised by Ms. Nalame Singharam, leading the team is Jun Bin, and with the help of Vanessa Lim Swantang and myself, Yukmar Moses. And before we go into our actual presentation, this is the table of content. Do you know that 90% of our milk products are exported from New Zealand and Australia? Yes, our country spent a whopping 1 billion US dollar for the importation of milk. Why? Lack of good labs for feed testing and low nutritious feed for our dairy companions are considered to be the main reasons for Malaysia to be ranked low in dairy production. To start off, our vision is to produce the most nutritional and value-added animal feed locally that can stimulate growth of related industries. So, our mission is to create high-quality animal feed using agricultural waste in order to reduce import of animal feed and environmental damage as much as possible. Before we move on to the method of making napan, here are the main materials we need. Firstly, we need napier grass, which contains high amounts of protein and fiber, widely found in Malaysia, easy to grow in large amounts and in a relatively short period of time. Banana peels are the second main material, as they contain a good amount of fat and minerals which are beneficial to the ruminants, followed by the addition of corn, molasses, and lactobacillus acidophilus. Next up, I'll be showing a short video clip about how napan is made in the lab. Firstly, we chop the napier grasses into 1 to 2 cm length and added them into a plastic bag. Napier grass can be cultivated in open space and in less arid land. Next, we added chopped banana peels, followed by corn, which can be easily digested by the ruminants, and we add liquid molasses to promote the fermentation process of lactobacillus acidophilus. The final ingredient, lactobacillus acidophilus, is being added to the silage to prevent clostridial damage in silages and silage preservation. With all the main ingredients inside the plastic bag, we give it a good mix by shaking the bag well. After removing most of the air from the primary bag, to ensure anaerobic condition, we put it into a second bag to prevent any entry of air into the silage. Finally, we tight seal the product and leave it for 6 weeks before we get our final product, which is napan.
We've made an analysis on the nutritional value in percentage of napan before and after the fermentation. As from the graph, we can see all the nutritional value aside from ash and crude fat is decreased after the fermentation, but it is not that significant. The change of the value serves as an indicator that the fermentation has occurred. Inoculants of lactobacillus acidophilus and molasses ensure the loss of nutrition is as low as possible while allowing a long-term storage. Lactobacillus acidophilus as an homofermentative lactic acid bacterium increase the silage quality by preempting unwanted fermentation by dominating the fermentation process in silage. Among all the values after fermentation, crude fat shows an increase which was crucial in maintaining a good weight and enhancing milk yield. Now let's look on the impact of the napan. So why do we use napan? The feed is considered to be more easily digestible compared to other forms of feed with a sufficient amount of fiber and other nutrition. With a balanced ratio of each crops, napan is high in protein, fiber, dry matter, and vitamins. Among these three crops, banana peels stands a crucial role when it comes to nutrition content. It contains metabolizer protein, which in this case help increase microbial protein synthesis. Other than that, banana peels and cones forages are agricultural waste that is often underutilized. The conversion of this agricultural waste into a useful material would thus bring a significant reduction of cost for the manufacturer. As mentioned, the main materials used are cheap in price and it is easy to obtain. By making the feed in silage one, it can be stored for a longer period. Also, with higher nutritional feed, the yield of milk will increase together with the quality of meat. Thank you.
We have a few suggestions to scale up the production. For a more efficient processing, a commercial shredder would be needed. Next, the grass should be harvested 6 to 7 weeks after planting, as at this period, water-soluble carbohydrates concentration will be at its peak which can prevent impairing in the ensiling process and increase dry matter content and nutritive values, thus improving the product quality. And now we'll move on to the problems accompanied by the ways to overcome them. The silage needs to be kept in an anaerobic condition for the fermentation to take place. Hence, a vacuum packing machine will be needed to remove the air and seal the silage for long-term storage. The high moisture content in Napier grass often leads to undesirable fermentation while processing it into silage. To overcome this, formic acid supplementation can rapidly decrease the pH value and is particularly effective in inhibiting undesirable bacteria such as enterobacteria and Clostridia. Lactobacillus acidophilus was added as it dominates the fermentation and prevents contamination in silage, which also helps to retain a good nutritive composition. Besides that, from a 2013 study, it was observed that the combination of Lactobacillus casei and Lactobacillus acidophilus is able to prevent undesired microbial and chemical spoilage, as well as improve the stability and quality of the product. Moreover, other materials such as molasses can be added to the silage. For instance, molasses improves silage quality by promoting fermentation and increasing lactic acid content, which reduces pH value. Here are some of the pictures throughout our journey. If you are interested in our product, here's a way to get connected with us. This marks the end of our presentation. Thank you for your attention.